Hello, this video is about graphing tangent and cotangent. Our essential question is, how do we graph tangent and cotangent function transformations? We're going to start off by talking about tangent and cotangent a little bit. Tangent of x is equal to opposite divided by adjacent, which derives from taking the sine of x and dividing by the cosine of x. So because of this, tangent of x is going to have asymptotes everywhere that the cosine of x is equal to 0. Because remember, we can't divide by 0. So those locations would include negative 3 pi divided by 2, negative pi over 2, pi over 2, and 3 pi over 2. It is also going to cross the midline y equals 0 at the midpoint of the two asymptotes. Now, to find these asymptotes, when we are performing a transformation of this type, we can find those asymptotes by taking what's in the parentheses here, bx minus c, setting it equal to one of our asymptote locations, negative pi over 2. And we can also solve for a second one, that is the next one over, which is pi over 2. If we solve for x, we'll be able to find out where those two asymptotes are located, and then from that we can follow the pattern and find additional ones. Go ahead and pause, copy this, and we'll continue on to talk a little bit about cotangent. Cotangent of x is equal to adjacent divided by opposite, which derives from cosine of x being divided by the sine of x. So cotangent is going to have asymptotes everywhere that sine of x is equal to 0. So those locations would include negative 2 pi, negative pi, 0 pi, and 2 pi. Cotangent of x will cross the midline y equals 0 at the midpoint of those two asymptotes. Now, when performing a transformation of cotangent, two asymptotes can be determined by solving bx minus c equals 0 and bx minus c equals pi. Those are the two easiest ones to solve for. And you can find those two asymptotes, and then again, once you find those two, you can continue to find other ones by following the pattern. So if you will pause, finish copying this part of your notes, and then we will look at a couple of examples. Example 1. We want to graph f of x equals the tangent of 2x minus pi over 2. And first thing we're going to do is we're going to label our information. So our a value is 1, which means that we really don't have any stretch for our particular graph on this one. Tangent is going to go up forever and down forever, so because of that we don't have a amplitude. Instead we have stretch, just like if we were graphing a quadratic or a cubic function. B is equal to 2. We're going to use that to determine our period of our function. And notice that the period of tangent and cotangent is going to have a different formula here, which I noted over here on the side. Instead of being 2 pi divided by b, it's just pi divided by b. So as I take and plug in the b value, we have pi divided by 2. So every pi over 2, we will have a repeat of our tangent graph. Our c value is pi over 2. So our phase shift, where we're going to be having our graph start on the midline, is going to be c divided by b. So if we take pi over 2 and we divide by the b value, which is 2, we end up with pi over 4, and this is our phase shift. Now this is a positive pi over 4, therefore it will be going to the right, pi over 4. Okay. Now if we look at the parent function of tangent, tangent of x when we graph it. starts at 0 normally, and then, as I mentioned before, it has asymptotes at pi over 2 and negative pi over 2, as was stated before in the previous little section. The parent, or the graph of tangent, will start at that midpoint of the two asymptotes, and then it will rise up to the right, and it will fall down to the left, and it goes forever in that particular pattern. Now notice how far apart these asymptotes are. They have a distance of pi between them. So if I go over another pi, in other words, if I go over to 3 pi over 2, I will have a repeat of that same graph. So halfway between, which would be located at pi, I have another graph of that same function. And then if I went the negative direction, I would have another asymptote at negative 3 pi over 2, and halfway in between at negative pi, I would have the midpoint of those two asymptotes, and then I would have my graph rising to the right and falling to the left. This is what the parent function looks like. So now when I graph the transformation, we're having a phase shift of pi over 4 to the right. So this one would be, this is my graph where tangent of 2x minus pi over 2 has a period of pi over 2, has a phase shift of pi over 4 to the right. So this time, instead of having my initial point starting on 0, my middle point, my midpoint between my two asymptotes, is going to be located at pi over 4 instead. And then the other thing I need to do is I need to determine what my asymptotes are. So let's go ahead and solve for those very quickly. Asymptotes, we take bx minus c, and we set it equal to negative pi over 2. We set it equal to pi over 2, and we solve it. Well, bx minus c is 2x minus pi over 2. So we're going to have 2x minus pi over 2 equals negative pi over 2. So I'm going to add pi over 2 to both sides. When I do that, negative pi over 2 plus pi over 2 is 0. So 2x is equal to 0. And when I divide by 2, I get x is 0. So at x is 0, I have one of my asymptotes. My second asymptote will be located at 2x minus pi over 2 equals pi over 2. I add pi over 2 to both sides. When I add pi over 2 and pi over 2, I just get pi. So 2x is equal to pi, and then I divide by 2, and I get x is equal to pi over 2. So at pi over 2, which is that next spot over, I have another asymptote. So you can see the distance between my two asymptotes from 0 to pi over 2 is the period, which our period was pi over 2, so that makes sense. So now I can just repeat that process. Every pi over 2, I'm going to have a new asymptote. So at pi, I'm going to have another asymptote. At 3 pi over 2, I will have another asymptote. And then halfway in between each one of these asymptotes, I will have a new midpoint, which is where my graph will start, and it will rise to the right and fall to the left. Rise to the right and fall to the left. Rise to the right and fall to the left. And then I can repeat this on the negative side at negative pi over 2. And then at the midpoint, rising to the right, falling to the left. And this would be the transformation of tangent of 2x minus pi over 2. So take a few minutes, copy this down, we'll do one more example. Okay, for our second example, we're going to graph y equals the cotangent of x plus pi over 2. First, let's talk about the parent graph of y equals cotangent of x. For y equals cotangent of x, remember before up here we talked about how we would have asymptotes at negative 2 pi, negative pi, 0 pi, 2 pi. Let's go ahead and sketch a couple of those on here. So we have one at 0. This is our parent at 0. We also have one at pi, and we also have one at 2 pi. And then you would also have them on the negative side, so you'd have another one at negative pi over here. So every pi distance, you have another asymptote, just like on the tangent graph. They're just shifted over. Just kind of remember how sine and cosine was a phase shift of sine. Well, same thing with cotangent. Cotangent is a phase shift of tangent. Halfway in between each one of our asymptotes, we have the midpoint again. The one thing that's different about cotangent from tangent, besides the phase shift, is that instead of rising to the right and falling to the left, we are going to rise up to the left and fall to the right. So it kind of goes the opposite direction. So it has a phase shift and it goes the opposite direction. So we're falling from the left side and then falling to the right side. Or you could say it's rising to the left and falling to the right. So this is what the parent does. So now as we work on this problem, I'm going to label my A. Again, on this one, the stretch is 1. So nothing is really stretching it. My B value is 1 as well. And my C value is the opposite of pi over 2, so negative pi over 2. And now as I look at the period, remember the period for cotangent and tangent is pi divided by b. So I'm going to have pi divided by 1, so our period is going to be pi. And then our phase shift will be c divided by b. So we have pi over 2 divided by 1, which is pi over 2. So we're going to be shifting, except, excuse me, that was a negative, so negative pi over 2. So we're going to be shifting to the left, pi over 2. Okay, pause for a moment, copy this down, and then we'll go ahead and do the graph. Okay, so now looking at our graph, normally our asymptotes would be located at 0 and pi. But if we find our asymptotes now, we've got x plus pi over 2 equals 0, and x plus pi over 2 equals pi. These are the two easiest ones to find. We're going to subtract pi over 2 from both sides. So we get x is located at negative pi over 2. So let's come over here to negative pi over 2. And for the second one, we're going to subtract pi over 2 from both sides. X is going to be located at positive pi over 2. So this is where our first two asymptotes are located. We're going to have a point at the midpoint between those two, and remember, cotangent rises to the left and falls to the right. And now if we repeat that process for our asymptotes, we will have another distance of pi. So at 3 pi over 2, we'll have our next asymptote. Halfway in between, we will have our midpoint rising to the right, or rising to the left, falling to the right, and then the same thing over here at negative 3 pi over 2. Another asymptote, and a point in the middle, rising to the left, falling to the right. Let's go ahead and finish copying this, and we will check them tomorrow. Have a good evening.